All right, today we're going to look at lesson 8.2. We're going to start with task 1, and we're going to graph absolute value functions. All right, so first we want to understand the parent absolute value function. Remember, a parent function is the simplest function in a family of functions. All right, so it says the parent absolute value function, denoted f of x equals absolute value of x, is a piecewise function given by the following rule. F of x equals negative x if x is less than 0, and f of x equals x if x is greater than or equal to 0. A table of values of the graph of the parent absolute value function are shown. All right, so you can see that they give you just your x's, and we got some positive and negative x's, and they plug it in, and when they do, this is your absolute value function. So you can see that the absolute value function is a V-shaped graph, and all absolute value functions are V-shaped graphs. All right, so describe the shape of the graph of the parent absolute value function. All right, so it would be a V-shaped graph. All right, which of the following statements about the parent absolute value function are true? Select all that apply. Its domain is the set of positive numbers. All right, so if we look at this, our domain is our x's. So it goes this way infinitely, and it goes this way infinitely. So since it goes both to the left and the right infinitely, it has more than just positive numbers. So its domain is the set of all real numbers, not just positive ones. All right, so what about the range? Its range is the set of positive numbers. All right, if we look up here, the range is your y values. Okay, so everything below the vertex here is negative. So the vertex is at 0, and it includes all positive value y's. All right, so the range is a set of positive numbers, but it also includes 0. So the range is a set of all non-negative numbers. Non-negative means 0 and positive. All right, and then it's not all real numbers because it does not include the negative numbers. All right, what are the intercepts of the graph? Select all that apply. Well, its x-intercept is at 0, 0. It has no y-intercept. And its y-intercept is 0, 0. Okay, so when we look up here, you can see that it intersects here at 0, 0. So this intersects on the x-axis and the y-axis. So the correct answer is both the x and the y are at 0, 0. All right, the point where the graph changes direction is called the vertex of the absolute value graph. The graph changes directions at the point 0, 0. Which of the following statements about the values of the function are true? Select all that apply. All right, the function has no minimum. Well, that's not true. It does have a minimum. You can see the minimum is the lowest point on the graph, and you can see the minimum is at 0, 0. So it does have a minimum, so we're not going to check that box. The minimum value of the function is at 0. Yes, that's true. The function has no maximum. Well, that's true as well because the arrows on the top of both sides show that it continues on forever. And the maximum value is this, the maximum value is that, so that is not true. So the minimum is 0, and it has no maximum. All right, complete the statements concerning the changes in the value of the function. All right, so the function is increasing on... It increases on the right side as it goes up. So from 0 to infinity, it increases. The function decreases as it goes towards 0, so that would be negative infinity to 0. The slope of the graph on the left side would be negative 1, and the slope on the graph of the positive side would be positive 1. All right, and again, all we're doing is looking at the two pieces of the function. So we're looking at this side, and then we're looking at this side. So this left side has a -1 slope, and this side has a +1 slope. You can see rise over run 1/1. All right, the line that divides the graph of the parent absolute value function into two congruent reflected halves is called the axis of symmetry. Which equation represents the axis of symmetry on the graph? All right, so the axis of symmetry cuts it into two equal symmetrical parts. And you can see right here, the line that goes through the vertex, that would be the y-axis. So the parent function, the axis of symmetry, is the y-axis. So that would be x equals 0. Because x equals 0 goes straight up and down through 0, which is the y-axis. All right, fill in the blank to describe how the function rule works for values of x that are less than 0, greater than 0, and equal to 0. All right, for any x less than 0, so that means we're looking at all the values to the left of 0, f of x would be -x. That's the function -x. Remember from the very beginning, right here, if it's less than 0, f of x equals -x. So then greater than or equal to 0 is equal to x. So that's all we're doing is looking at the separate pieces of the function. For any x greater than 0, f of x equals x. And when f is 0, y is 0 as well. All right, explain why the piecewise definition of the parent absolute value function has two parts. So it's going to have two parts because you've got two different lines. So you got f of x equals -x. It has a negative slope, and then you've got f of x equals x, which has a positive slope, and together they meet at the vertex. So it does form a piecewise function. All right, what is the minimum number of points you would need to plot in order to draw the graph of the parent absolute value function? All right, so anytime you have an absolute value function, you've got a V-shaped graph. So let's say you got the vertex and you've got 1 point on each side to make the V. You should need at least 3 points, and one has to be on either side of the vertex to make it your V-shaped graph. If you pick 2 points on the same side of the vertex, you're just going to get a straight line. So that's all for task 1. If you have any questions, please let me know. All right, we are on lesson 8.2, task 2. We're going to graph transformations of the absolute value function. You can translate graph of a parent absolute value function, f of x equals the absolute value of x, by changing the values of h and k in g of x equals the absolute value of x minus h plus k, where h and k are real numbers. Compare a translated graph of the parent absolute value function with the graph of the parent absolute value function. All right, so we want to compare the translated graph with the parent function. You can see that the blue function here is the parent function. F of x equals absolute value of x. So we looked at that in task 1, how the vertex is at 0, 0, and it has a slope of -1 on the left side and +1 on the right side. All right, so let's evaluate g of x, where x minus 3 plus 2. All right, so you can see that it has moved to the right 3 and up 2. So your vertex is determined by h and k. It still has a negative slope on the left and it has a positive slope on the right. Now you can see the axis of symmetry would be x equals 3, and everything looks the same except this graph has been shifted to the right and up. Okay? All right, so it says, how is the graph of g translated from the graph of the parent function? All right, so we just said it's moved to the right 3 units and up 2. All right, which of the following statements are true? Select all that apply. All right, so the coordinates of the vertex are 3, 2. All right, the coordinates of the vertex, if we come over 3, 2, that is true. The axis of symmetry is x equals 2. X equals 2 is right here. That's not true. The axis of symmetry is x equals 3. The y-intercept is 0, 5. All right, 0, 5, that is the y-intercept, so that one is true. And the minimum value is 2. So the minimum value is the lowest value, and that is 2. The y-intercept occurs at 5, 0. All right. 5, 0 would be over 5 up 0. That would be right there. So that's not true. It was at 0, 5, not 5, 0. So the last one is not true. All right. Which of the following statements are true? Select all that apply. All right. So the domain of g of x is all real numbers greater than or equal to 2. All right, so again, just like the parent function, we show the domain goes left and right forever with arrows. That means the domain is all real numbers for both the parent function and the translation. So that is not correct. And let's see, the range is all real numbers greater than or equal to 2. So the range is everything above 2. So greater than or equal to 2 is true for the range. The domain is all real numbers. The range of g of x is all real numbers. That's not true. The vertical translation changes the domain. No, the vertical translation changes the range. That is true. All right, so you can see that it does not change the domain because both of these have arrows. The parent function and the translation go in both directions, left and right forever. What it did do was shift up 2, and the vertical line is your range. So that's why we chose the last one. The vertical translation does change the range. All right, that's all for task 2. If you have any questions, let me know.